This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's great to be back, and we've got a super guest for today. Lan Chi Nguyen Weekes is going to talk to us about IEQ operations and maintenance and the management of Legionella in water systems. Before we start, let's thank our platinum sponsor.
IAQ Radio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com.
I also want to thank our gold sponsors, Particles Plus, Healthy Indoors Magazine, Gray Wolf Sensing Solutions, and AEML Inc. Laboratory. And of course, our association sponsors, CIRI, the Cleaning Industry Research Institute, the Indoor Air Quality Association, and the Restoration Industry Association.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everyone. The IEQ Radio Trivia question for today, Friday, the 13th of September, 2019, has been sponsored by Ideas, a solution chemistry company providing unique solutions to odor removal, surface cleaning, and decontamination problems. Here's today's trivia question. Name the hotel in which the 1976 outbreak of pneumonia infection occurred in Philadelphia. Back to you, Joe.
All right. Thank you, Cliff. Okay. Today's guest is Lan Chi Nguyen Weekes. She's currently the Director of Physical Resources at La Cité, a college in applied arts and technology in Ottawa, Ontario, Canada. She was the co-founder and partner of InAIR Environmental, an environmental consulting company, from 1995 to 2018. And we've had her and her husband, Don Weekes, on in the past. In fact, Don has been a pretty frequent guest of the show. Ms. Weekes has over 28 years of consulting experience on environmental issues, including the interactions between buildings and human health. Currently, she is working on the implementation of a Net Zero Carbone strategy for the La Cité campuses. And she's addressing the issue of Legionella in building water systems and assessing the impact of climate change on indoor air quality. Lan Chi, welcome to the show.
Hello, Joe. Hello, Cliff. Thank you for having me.
Great to have you.
Pleasure.
Love talking to you, and looking forward to the interview today. You made a big change here not too long ago. You went from your own environmental consulting company to working in facilities at a college up in Ontario there. Mm-hmm. I'm wondering what kind of, tell listeners a little bit about how that's impacted you and what the differences are between having your own company and then working for a college like that.
Well, what's really different is really that now I'm going from being a consultant to being a client. So the mindset is quite different, from being one or the other. And the other big impact is I don't get to work with my husband, Don Weekes, anymore on a daily basis.
Okay. Well, that can be good and bad, right?
Yeah, well, no comment.
Anyway, so let's start a little bit with the college, because I think we can always relate indoor air quality to college campuses, and they have all kinds of different issues. First, how many buildings, how big of a college is it?
Well, we are considered to be sort of small to medium college. I have 12 buildings under my responsibility over 2 campuses. And, like anything, we have residences, classroom, laboratory, common area, and so on. So it's fairly typical campus, really.
What are the primary, since you've been there now, it's been a little more than a year now, is it?
2 years and a half.
2.5 years. So what have been the most common IAQ related issues that you've had to deal with?
Well, I have to tell you, it's not even IAQ, it's more indoor environmental quality. You know, we hear about it all the time, but it's really just temperature control. That's what we hear about. You know, it's really, really hard to satisfy everybody, especially in a very large transient group. You know, people move from class to class and you try to accommodate 30 to 50 people within 3 hours and they move on to somewhere else, you know. So that's the biggest thing.
Temperature.
Yep.
Okay. And Cliff, did you want to jump in?
No.
Okay. I thought maybe I heard you. But anyway, when you're dealing, let's talk a little more about the campus. Do you have mechanical system? Do you have like a central system, or is it building by building?
No, we have a central heating plant, but we also have 600 heat pumps, right? The original design was that each of the classroom or each of the space was going to have its own dedicated unit. So it's a bit of a challenge, you know, to keep everything maintained and clean and so on, but we're doing it. It's just part of what we need to do.
Okay, and it's primarily a heating environment. Do you have any air conditioning?
In some building we do, in some building we don't. You know, again, it was built as one of these schools where they thought, wow, we don't teach during summertime. Yes, we do.
Okay.
They're used during summertime. So I'm looking to change all of that mechanical system now.
You know, we talked a little before the show, and right now you're working on an energy program. You're trying to, I guess, figure out how much energy the school uses before you start to figure out how to, you know, how to maybe implement some energy management and maybe save a little money on that. I also understand you're contracting some of that out, but that you're kind of overseeing all of that. How big of an impact, and maybe you don't know, does the energy budget have at a school like that? You've got a fairly small campus, but I would imagine it's a fairly significant percentage of the costs.
It is, Joe. I mean, especially, you know, in Canada, where you have quite extreme temperature when you really think about it, the difference between winter and summer. I mean, people think that, you know, summer in Canada, you still have snow. No, it goes up to 100% relative humidity easily during summertime. So we have quite a swing, and we have energy costs like anybody else. So we really do have to control that, especially in a fairly, we have a very large operating hours. You know, we open from 6 o'clock in the morning to 11 p.m. So we have to keep the condition acceptable for everybody here. Interesting.
And with respect to relative humidity, is that difficult for you to control with the type of central system you have up there?
Yes, it is very difficult, especially in some buildings where we don't have AC. We can't even, and I don't like to do that, but we can't even use air conditioning to try to humidify, right? So we try to minimize the outdoor air, but you have to ventilate. You have to provide minimum outdoor air. So sometimes you just live with the consequences.
Unfortunately, huh? Well, let's talk a little more about that ASHRAE. Actually, I didn't mention this in your introduction. I had a little longer bio, and I didn't read the whole thing. But one of the things you're doing is you're part of the ASHRAE Multidisciplinary Technical Group on Health and Wellness in the Built Environment.
Yeah.
And I wasn't familiar with that, and then you kind of enlightened me before the show that it's a fairly new committee.
Yeah.
Listeners, a little bit about what that committee does and what they mean by health and wellness in the built environment.
So I'm actually the chair of that working group, and our mandate has been really to help, you know, and expand internal and external organization partnership on the topics of health and wellness, especially between organizations that rate high performance building, research institute, and government agency. So when we're starting to work on that, I think one of the first things we need to know or, you know, define is what is health and wellness. We're working on that right now.
That's a great question. In fact, last year at our conference, I think it was last year, maybe the year before,
Mhm.
Carl Grimes did a discussion of health and
Yeah.
all the different definitions of health. What is health?
Yep.
Are you making some progress in defining what health is?
Yes, and you know, we're not trying to reinvent the wheel here. The World Health Organization, different association, work from Carl's, you know, within ASHRAE is there. So we're gonna hopefully try to build on that and come up with ways to use that definition, and then get all these different partners together to work on, you know, where do we take this? You know, how do we incorporate that in the built environment? And we're not just talking about buildings, right? We're talking about everything else.
Oh, really? Okay. So is it airplanes, or, I mean, when you mean everything else?
Well, we're hoping that it's going to be whatever it's man-made when you really think about it. But under ASHRAE, it's really the built environment. So certainly we're targeting the buildings environment, but hopefully that definition can be applied to anywhere humans occupy the space.
Interesting. Now, the other group that you were working with, and they recently put their report together, was the Management of Legionella in Water Systems, a committee of the National Academy of Science, Engineering, and Medicine. And the final document's been released, and I'm just wondering, how long did that take? National Academy of Science is pretty rigorous with their requirements for these kind of documents. How long did a document like this take to put together?
Well, in this particular case, Joe, it took 18 months to put together. And the work group was 13 members, plus the Academy staff, of course, that support us in this endeavor.
Interesting. And it says that it was an ad hoc committee to review the state of the science with respect to Legionella contamination of water systems and issue a report on the following: ecology and diagnosis, transmission via water systems, quantification, prevention and control, policy, training issues, research. I'd like to kind of look at those topics and get an overview on what the committee felt, you know. So talking about ecology and diagnosis. They say here that they're going to try and describe the microbial ecology of water supplies as it relates to Legionella, what species and strains, etc. Tell listeners a little bit about that topic and what was found.
Okay, so for those of you who are not familiar with Legionella, it is a bacteria that found naturally in many rivers, lake, and soil. And we've heard about that. Can also flourish in pipe, in tank, or other component that's man-made that can contain water. A combination of stagnant water, warm temperature, building material, lack of disinfectant can encourage growth that is beyond what we qualify as normal growth. So that's where the ecology of water is for Legionella. It lives within an amoeba that colonized biofilm, and biofilm that's really sticky, you know, slimy stuff stick around in equipment or pipes that contain water. That's what the ecology of Legionella mostly is.
And when you were looking at this, I think this may be the section where you were looking at, okay, is it all Legionella that causes health issues? Is it certain strains and things like how can we more quickly evaluate or diagnose a system and determine whether it has that type of, that strain? Is that accurate, or was that in another section?
Well, no, I mean, this is where we talk about it. And, you know, one of the surprising things that we found is that a lot of study has been about Legionella monophila, but it's not the only Legionella species, right? I mean, there's Legionella. But what has been reported in the literature is the Monophila serogroup 1. So one of the urgent needs that we found in doing this review of the state of science is that we need to develop better clinical tools to capture more of the Legionella disease and identify the species and the genus that cause the disease. Because right now we're just testing for one. We're just testing for the Legionella pneumophilia serogroup. So we do more, validation between qPCR and other tests and so on, so that we can do faster tests and correlate better, what we are seeing, basically.
So, in essence, what the group did was they looked at what's existing.
That's correct.
What's existing, and then they made recommendations for where we need further research.
That's correct. If you look at our scope, it was really to look at the state of science, right? So what the science out there shows.
Okay. And then to look at gaps that maybe exist, and then how to fill in the gaps. Are we making any progress on finding the strains that cause these issues and maybe improving the diagnosis?
As I was saying, we need to have better detection tools. That's one thing, to identify the specific species. We need better reporting. Surprisingly, the reporting is sketchy, because people are not necessarily being tested for Legionella as the first reaction, if you want, when they show up, at the hospital, at the emergency with pneumonia. Typically people get sent home with a sort of broad range antibiotics and, just go home, take this, hopefully it will get better. And a lot of cases get better. So they don't get to the level of testing for Legionella. That's the first thing. And the other thing is, surprisingly, it's not, when you have an outbreak or there's Legionella disease, the environmental testing is not very frequently done. So there's the disconnect between the clinical and the environmental, meaning that you may have an outbreak, but you don't know where it's coming from. And a lot of time when you have an outbreak and people say, well, we think it's coming from a cooling tower, or we think it's coming, a hot tub somewhere, they think. It's not always necessarily true, and we don't necessarily know for sure that it's coming from that particular equipment.
Interesting. Cliff, did you want to jump in here?
I did. I just had to talk about this. On my way to the office this morning, I needed to stop for fuel because my gas tank was virtually empty. So I stopped there and I go to clean my windows. And, they have this little tank there with the squeegee in it and the liquid. And, it's like 80 degrees. I'm coming to work. And I stick it in. I wipe it across my back window. And all of a sudden, it's that smell. I mean, it smelled horrible. That water was so contaminated. And I would not be surprised if those tanks are not a typical source, that would be a great reservoir for Legionella and a bunch of other nasty stuff, and people don't even think about it.
No, not until you just mentioned it. Now, point. Let's go to the next bullet point I have with respect to what the committee's report was on, and the second was transmission via water systems. What are the primary sources and routes of human exposure to Legionella? I know we've all, you mentioned a few earlier, but do we really know? I mean, that, it's cooling towers, or it's hot tubs, or it's whatever. Do we have any idea how often it's the cooling tower versus the hot tub versus the hot water tank?
Well, we know only when it's reported, right? And that's the problem that we have right now. But I want to go back to Cliff was saying. I think what is really important is to remember that as far as we know, Legionella is a respiratory disease. First of all, you have to breathe in the contaminated water, either because it's in the mist that you're breathing in, or you aspire the water. So that's what we know, that most of the case, except for one that we heard of, that transmitted from person to person, all the cases that we heard of has been by inhalation of contaminated water. water is contaminated and you're not inhaling water, or you're not inhaling the mist coming from that, chances are it's not going to be necessarily a problem. It's just sitting there in the water. Is you have to breathe in for it to be a potential for problem. That's the first thing. And what caused water, do we know more if it's come from cooling tower or for hot tub? It's really not that much an issue. I think the issue is a combination of issues, of material that's been selected for these equipment, how they've been maintained, if there's stagnant water, what the characteristic of this water supply, what kind of temperature the water being maintained, how much chlorination or disinfectant we have in these water. So it's really a combination rather than a particular piece of equipment, if you see what I'm saying.
I see. And is it just seems to me, and I don't know, maybe I'm wrong, that as far as inhalation of water,
yeah,
common way I would be inhaling water droplets on a regular basis is taking a shower.
That's correct, yes.
Is that a real common way of developing Legionella?
Well, in some cases, yes, it's been, especially in location where water's been stagnant for a long time. And that section that we refer to as the distal tap, that little pipe section between your water main and your shower head, little section of pipe that's just sitting there, having hot water at some point, but cool down over time. And then if you were away and haven't taken a shower for several days, you could have growth going on there. So in a lot of cases, it's been from shower heads, but not strictly from shower heads.
Would it be a good recommendation then to let people know, look, if you have been away for a week, you haven't taken a shower in a week because you were away or for whatever reason, maybe let the water run a little bit longer before you get in the shower, although that's going to cause an energy penalty. But I don't know, what do you think of that idea?
Well, since we haven't done any, I could say tests to make sure that it worked, I can't say that that's something that I will necessarily recommend, because you still stick your head in there and try to turn on the shower, right? So what happened is the first couple of droplets that you may receive, and you have to remember that in some cases, we know that for cooling towers, the droplets can travel very far. So yes, it could be the shower head at your place, but it could be, the mist of the plume of some cooling towers up to 7 miles away.
7 miles. Wow. Yeah. I didn't realize that. And that's why they're in New York City, they're now requiring, I guess, that you register your cooling towers and that you treat them on a regular basis.
Yes. Yes. And in Quebec also. In Quebec.
Oh, really? That's probably good for the environmental consulting world up there.
It's good for the water treatment people.
Lan Chi, I've got a question. Okay.
Yes.
To me, it seems somewhat improbable for a droplet to travel a great distance and still be wet when it gets there. Mm-hmm. So it leads me back to what I had said earlier. This water stunk. Okay.
Yeah.
I know it stunk because I could smell it.
Yeah.
And for me to smell it, something had to get in my nose, whether it was dry, whether it was wet, whether it was gaseous, or whatever. I mean, do we really know that it has to be a wet mist? I mean, is that absolutely positively that it has to be a certain size droplet? Or, can it be vapor that we get because the moisture is already in our nose, it's already in our body, so I kind of find it hard to believe it's some specific droplet size, but I could be wrong.
Yes, because it's not really a gas. It's a living organism, so it has a certain size. If you see what I'm saying, it has a certain size. It's not you have to have a certain size to harbor or to protect the bacteria. So the droplets, the reason why Legionella is so hard to control and to kill is because it's kind of live as a parasite within something else. So does something else act as its sort of protective armor? So that means that there's a certain size to that thing, right? I mean, it's not or anything. It has to have a certain mass to it. So I think that's where, but again, you know, I hear what you're saying. I mean, there's not enough work done for us to say for sure that, you know, it's not the smell of it or the vapor of it. What we know based on the studies that's been done out there is that a certain size of droplets that you breathe in has caused disease. Mm-hmm. That's what we can tell based on the studies that has been done.
Okay. And then I've got a text question from a listener. Are the majority of identified Legionella infections cases specific to a particular application? So he's mentioned like cooling towers. And I think you sort of answered that, but I don't know. I mean, with what we have more cases been related to cooling towers than to say whirlpools or hot water systems?
What the committee has found is that a lot of cases are travel related. So is it from cooling towers? Is it from, you know, unused shower in a motel, in a hotel, on the cruise ship, whatever it is? That's the predominant number of cases for Legionella. They're not necessarily an outbreak, so that's a different thing. An outbreak is more than 2 or 3 person, you know, having the same thing sort of about the same location. But the bulk of the Legionella infection that we've seen based on the studies we look at are travel related. So in some cases you hear about cooling towers, but when you step back a little bit, it's the outbreak from cooling towers actually are very small compared to everything else that's happening.
Lan Chi,
it's in the report.
I guess I have a question. Would you say that exposure is very widespread, but that the number of people susceptible to it is much smaller, because that's going to be, you know, someone who has a you know, an inability perhaps to, you know, to fight it off. So you think a lot more people are exposed to it, but few people actually get it.
Yeah, I think people are exposed to it. You know, like any other disease, a lot of people get exposed, and it depends on a lot of other factors. You know, you're more susceptible. We always have these groups that we are concerned about. Elderly patients or immunocompromised patient or children and so on. So it's the same thing basically for Legionella. Our suspicions is a lot more people exposed and not being reported, and a lot of people are being exposed and not necessarily having symptoms. Now you have to remember that the other side of Legionella is called Pontiac fever, and it's milder illness, and then people, you know, take aspirin or whatever or some other medication and it goes away. So you haven't gone to the point of testing, has I been exposed to Legionella, right?
Lan Chi, are Legionella sources geographical at all? Like, do we have more of a problem in North America than in other countries?
I really cannot tell you, because we have not done necessarily, there's not enough studies done necessarily to quantify where Legionella is. We know it's present in nature. It's a natural thing. It's not it's a natural bacteria. So I would suspect that it is elsewhere, right?
And is there any, if you were exposed as a young child, let's say, to Legionella, you maybe had a milder form, Pontiac fever, does that give you any protection from maybe getting Legionella down the road?
I don't think I can answer that, Joe. I don't really know. And I don't think that any of the study have shown anything of that kind. Okay. So I don't know if anything has been done to study that.
Understood. I just thought it was, it just came to my mind when you mentioned people traveling. That really caught me by surprise that was the most common thing you found with respect to cases of Legionella. And I was thinking, well, maybe we get some kind of immunity buildup or something. That's interesting. I guess that's why they're studying this stuff. All right. Well, Was there anything in that first two sections, ecology and diagnosis and transmission via water systems, that kind of surprised you?
Well, what surprised me the most when I was working on this is that it's not, we talk about, well, is it cooling towers or is it a piece of equipment in particular? It's not, it seems to be a combination. You hit the right combination sort of thing, it's going to encourage growth. And whatever you do, a small change in that sort of, matrix of parameters can affect the growth or inhibit the growth. So, the dice is pretty loaded here. I mean, it's hard to say one single thing going to fix this problem because there's so many factors involved.
Interesting. All right, we'll be back in 90 seconds with our guest, Lan Chi Nguyen Weekes.
IAQradio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Gold sponsors are Particles Plus Engineers and Manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLinc.com. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at IAQA.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org.
CIRI, the Cleaning Industry Research Institute. See more deeply through science and research. Learn more at ciriscience.org. That's CIRI science.org. All right, we're back. Second half of our interview. We've got Lan Chi Nguyen Weekes, and we've been talking Legionella and facilities management. And I want to go into the quantification section of the report on Legionella, considering surveillance data, case studies of outbreaks, etc. What is known about the concentration of Legionella in water systems and the prevalence of Legionellosis over the last 20 years? Seems like we've hit that fairly good. Was there anything else you wanted to add on that topic?
No, I think so. I think we've done pretty well.
All right. How uncertain are these estimates? So that was something you did mention. We're really not that sure on these estimates, are we?
No.
Okay. And
we know what's been reported, right?
That's it. And is there any idea, like any theory on, we get one reported case out of probably 10 out there?
Yes, that's about right.
Oh yeah, not bad, huh?
Underreporting, it's between 8 to 10-fold.
Interesting. Okay. And my question is, with Pontiac fever, is that similar? I mean, it seems to me you'd have even less reporting on that.
Oh, absolutely. You basically have no reporting on that.
Okay. Interesting.
Or very little, as far as we're able to tell.
And you were going to look at how that quantitative risk assessment, how can that be improved? So how can we improve that?
Well, we have to figure some way, because what we've seen in going through all these studies is that there's clinical tests, there's environmental tests, but there's not correlation between these two. So if you have an outbreak, you need to go and test the water or whatever, to try to see where that is coming from. Again, as I say, surprisingly, the environmental testing is very infrequently done, even in the reporting of an outbreak. So we don't really know where it's coming from.
Interesting.
How do you know it's coming from this tower? Maybe it's a combination of towers. Maybe it's a combination of that tower plus that hot tub plus something else. We don't know.
How do we fix that?
Well, if we start managing everything on a more consistent basis. So, what we've seen is that the requirements are quite different. So in New York City, there's a requirements to register all the tower. In Quebec, there's a requirements to register the towers and to test the water in the tower, right, on a regular basis. So I think if we can have consistency about how we treat public water, how we treat cooling tower, how we treat different piece of equipment and water feature, then we can say, well, we can see the difference in the results or not or whatever. Talk better, because right now it's very all over the place, basically.
Well, I'm sure a big part of the reason we don't test more often is the cost.
Yes.
How big of an issue is Legionella compared to other types of indoor environmental quality issues? And this is something obviously that is probably just an estimate on your part. I don't know that we have that quantified or not, but in your experience, you've been in this for 30 years, you're now working at a college. How common is Legionella?
Well, it's only as common as people report it to us. And a lot of time it's not reported to the facilities, it's reported to the public health people. Public health go and do their thing, right? We don't necessarily hear about it from a facility point of view because they don't know where the disease was acquired. So the person could have acquired this, when they were traveling or in our facilities and so on. So it's very hard for us to know if Legionella disease come from our facility. Just so you know, we don't have any at my facility. That's right. Based on, the committee has been able to do some projection based on the studies that we have reviewed. And we estimate that about 52,000 to 70,000 cases of Legionella happen in the United States every year. With, as I was saying earlier, an under-reporting factor between 8 to 10. So we report about 5,000 cases, but really we think there's more like 50,000 cases.
Interesting. Because it always becomes, and you're working at a college now, and it becomes a financial thing. Do we put the money into the managing it? Do we put the money into the testing? I'm guessing, and I could be wrong, correct me if I'm wrong, where you're at now, you're putting the money more into managing?
Yes, we're putting the money in managing, and I think it's just good diligence to do so, right? Good practice to do so, to manage properly than trying to do it in a reactive way.
I got a text actually here that says the report states the committee arrived at an estimate of 52,000 to 70,000 cases per year in the United States. How was that estimated?
Well, I'm not an epi person, but on the committee there was epi people who worked to that number basically. So I apologize. I don't want to explain the wrong thing because again, I'm an epi person, but it's detailed in the report.
Sometimes that's the best answer,
I don't.
Let's go to the next subject here. That was prevention and control. Okay.
Yes.
So prevention and control. I guess I don't want to get too far behind here. So why don't we go ahead and have you just pick out what are your highlights? First, what surprised you about prevention and control, if anything? Secondly, what are the highlights from the report about how to prevent and control?
I think that, what surprised me again is that in the water system, or if you look at the water system in the building, there are a lot of factors. It's not just a single factor. It's not that easy to say, temperature going to do it or material going to do it. It's really a combination of the material, of the pipe, of the vessels, the water temperature, the water characteristic, and so on. But we have made a couple of recommendations based on what is already existing. And please do remember that this is focusing on the US. So some of the things that we have thought that could be really useful is that if EPA could require a minimum disinfectant residual, right, of chlorine throughout public water system. So that means that we control what kind of water go into a building. Also requiring monitoring for Legionella in the public water system. Now, I mean, to be honest, this was made not necessarily with monetary consideration or anything. This is made from a scientific consideration, right? So
if we had all the money we wanted, what would we do?
Yes. So then we will want to make sure that people register their cooling tower. From a public health point of view, it's easy when there's an outbreak to know if you already know where your cooling towers are. Not saying that cooling towers are the only thing, but it's help public health to identify or rule out, if you want, any potential problems from cooling tower. We have suggested that from an operational point of view, that you require hot water to be maintained at 60 degrees at the source point, and then at the distal point at 55 degrees C. I'm sorry, I don't know what it is in Fahrenheit. We use the metric system in Canada. What we know is that it's not encouraged in building code because of scalding issues. So we make sure that, again, there's other issues, but from a scientific point of view to control Legionella, we suggest that at the point of use that you maintain 55 degrees C. We suggest that you expand the Centers of Medicare and Medicaid Services memorandum to require that Legionella be done in water samples, that environmental water samples being done. Right now, the memorandum only requires that the facilities do a water management plan, but it doesn't require regular environmental monitoring of the water, basically. So, and it's highly enforceable. It's easy to enforce because facilities that don't do it, they don't receive the money, right? So it's easy to enforce in that case. And that's the kind of things that we try to do with the report, is to build in policies or regulation that are already existing and just stretch them a little bit to help, take it one step further to help us better quantify, better study the Legionella issue.
That's common sense recommendations, and it doesn't sound too terribly expensive. Some of the testing for the public water systems is a little, but they're already sending it out for testing anyway. You add the Legionella, I assume. Yeah. Okay.
And if we can improve the methodology, then the price is going to come down, right? So.
Yeah, that's a big issue, right? What ballpark idea? What does it cost for a Legionella analysis?
If you do the gold standard method, which is the culture method, I believe it's about $100.
What method was it? Look up on me.
I'm sorry?
What was the method again?
The culture method.
Okay.
Sample, it's at sent to the lab, and there's a culture that's done. It's about $100 plus minus in that range. But there are companies out there that are coming up with qPCR method and for detection and so on. So we just need to make sure that validation is there. But otherwise, these methods can be easy to use, a little bit like mold, basically.
When you were talking about the different types of pipe and so forth in the system, and it led to a question for me there. Is there you've got PEX, you've got PVC, you've got copper, you've got, 5-6 different. Is there a type of pipe that's more likely to harbor Legionella?
There's a type of material, yes, but it's also depend on your, the source of your water. It depends on your maintenance. It depends on, as I was saying, other factors than just the material. Mm-hmm. Studies that show that some type of pipe material are better than others. And again, you're not looking at the other factors.
Right. I mean, if there's no Legionella in the water coming into your building to start with, well, it doesn't matter what kind of pipe you have.
Exactly.
Okay.
But then if there's coming in and then you maintain it properly and you disinfect properly, still not a problem.
And
right?
Did you recommend a particular, I mean, there's an ASHRAE standard on Legionella, there's OSHA, there's AIHA has something on Legionella. Did you recommend a particular standard or guideline for the disinfecting?
Well, I think that you have to look at all these guidelines, right? And what I like about these guidelines is none of them are right or wrong, in the sense that they address different stage of the process, right? So, some talk about sampling. The AIHA document talk extensively about sampling and analysis and so on. Other document address how to create a water management plan and making sure that everything's taken care of. So what I would suggest that people who don't understand what's going on or need to start, there are documents that help you start. CDC have a very good document on how to understand what you need to do in terms of getting a document together. So I think that's good for people. ASHRAE document talk about the intent of writing one of these documents and who should be involved. So it's good to look at various documents and go and look for the information that you need from each of these documents, because they address it depending on their expertise and depending on their audience. One of the topics is more explored than others.
We're kind of into the prevention and control now. We've been kind of discussing that a little, prior to my even bringing up that section of the report. We've had several people on from the Pittsburgh VA, for instance, that used to work there, and they had these very kind of complex system, I thought, for controlling Legionella, that they were using some kind of silver and other a combination of things. And of course, they're working in a facility where we have a pretty compromised group of people. They're in a hospital to start with, the VA hospital, a lot of elderly people in there as well. I'm wondering,
they've had problems in that hospital.
And exactly, they've had problems in that hospital. So it seems to me, and then they had Dr. Stow and the other doctor there, they were on staff, primarily dealing with that. It sounded like it was really expensive problem for them to deal with. And I don't know that other hospitals go to that extent. I'm just wondering what your thoughts are on that. Does it have to be that complex and that detailed?
Well, I know that some other hospitals, some private hospitals, go to that extent and beyond. For example, we now have fixtures that automatically flush if the room is not being used for a certain time period, and so on. So, but to go back to what you're saying, the difficulty with the complexity is that we don't really know that well how all these control methods work, if they're working well. Because some studies have shown that, yes, you may shock chlorinate, but it become more resistant, right? Because it adapt and it become more resistant. So unless we start really doing proper testing, laboratory testing and proper study, we don't know if it's working all the time, which work better, and so on, right? I mean, there's work that's been done, but there's so many variables that enter into the growth of Legionella in any water system that it is not always possible to control all the parameters when you're doing these tests.
And when it comes to these, can you kind of, like you mentioned, shock chlorination, what other systems did you look at for control of Legionella?
What we found most effective is that you maintain the water temperature. Like if you are supplying hot water, maintain it above 60 degrees C, right? Maintain it outside of the growth zone. So when it's very cold, we know that Legionella might be there, but it's dormant. It's not it's not doing anything. And when it's very hot, above 60 degrees C, the rate kill is about 1 to 2 minutes at most. So you try to keep it away from the proper temperature range, which is about 25 to 30 something, 40 something, depending on the environment. But you want to keep the water temperature away from that range, if possible.
Wow.
And that's the most simple, effective way that we know to control. The other stuff can be added, can be used, material, chemicals, and so on. But to what extent and what combination, we don't really know for sure.
So now I have a quandary, and so do you. You're a facilities management person, right?
Yes.
And at 60 C, I'm not sure what that is, but I'm pretty sure that's well above the recommendations for hot water supply for scalding.
Yeah.
So I'm in a quandary. As a facilities management person, what do I do? Keep it at 60 C or back off? And, what's more important, the scalding or the potential for Legionella? And are there methods for keeping it at 60, but then having some kind of prevention with respect to scalding?
Yes. Well, you know that they have mixing valves and all that kind of thing. And we have some concerns about mixing valves also, because there's still that distal distance, that little pipe between the mixing valve and the actual outlet. There's always a little space there, right? But what we're saying is at the boiler, at the water heater, you have to keep it at 60, right? And we know that there's some heat loss, some temperature loss as you go through the system. As long as you make sure that the water is circulating, that's the other thing. You want to avoid stagnation. Water is circulating. The water has been returned to the heater and kept at 60 degrees at that location, then you're avoiding a lot of the problems.
Interesting. All right, let's talk real quickly about, we're getting a little short on time, the policy and training issues.
Yes.
There was a section on policy and training issues. I just wondered if you could mention any highlights there that you thought would be important for listeners.
Well, as I say, we have said that the different policies that's already in place, we see that these policies can be expanded to help control Legionella, to include the control of Legionella. So that's well covered. In terms of training, I think that, the people that are easiest to train are the HVAC people, or the people that deal with water system, to train them to understand that there's an impact, from what they're doing. The maintenance is a big thing, and then they need to deal with it. So I think that there in the document there's a plan for what we think training and what kind of training and who should be trained and so on. That's in the book also.
Okay.
It's free. So it's free. So you can get it through the National Academy of Science for free. So I encourage people to get it.
We'll put that link in the blog so that people can go ahead and get that. There was one other thing while we were talking about that came to my mind. Okay. You mentioned the HVAC guys and the cooling towers. Did you look at what types of, they'll use a tablet, for instance, in the cooling tower to help disinfect. Did you look at what works best with respect to that?
Oh, you mean the biocide and things like that, water treatment?
Yes.
Well, what we have said is that the water treatment really depends on the quality of your incoming water. Okay. Right. So, and it depends on how you want to operate your cooling tower. How much blowdown do you want? How much water loss you want to mitigate? How much recirculation you want to do. So all of that has to be taken into account when you do the water treatment. So I can't say that there's a single water treatment going to work better for you. It's really depend on how you use your cooling tower.
Okay. And the last section was research. So what did you guys recommend with respect to, and I can imagine some of it just from our conversation here, but maybe we could kind of summarize for people what areas do we need more research on? What don't we know? Or what do we think we know that we maybe didn't know as well as we thought we knew?
Well, I think that surprisingly, we've seen that there's a lot of data, a lot of protocol that's been put, not necessarily in the US, but in other countries in Europe. And what surprised us is that we don't know much from that, right? I mean, some country has gathered thousands, if not millions and millions of data points on environmental testing for Legionella. And what does that tell us? We still don't know where it's coming from. We still don't know how it's controlled. So I think there's a lot of research that needs to be done to correlate the clinical data with the environmental data. And we need to kind of, normalize the way we treat and maintain, our cooling towers, our water, our public water, and so on. And I think that from there we can, then do research to get us to a point where we hopefully understand the disease and the growth a little bit better.
Interesting. All right, Cliff, before we wrap things up, did you have anything you wanted to add?
I did. If you could comment on biofilm, it seems to me that if you have biofilm, you're going to have a problem. If you don't have biofilm, can you still have the problem, I guess?
Well, I think that the biofilm is one of these interesting things. And I can tell you that, again, I'm not a specialist in biofilm, but there were biofilm specialists on the committee. And sometimes discussion for hours about, how biofilm, the thickness of the biofilm, and so on. It's appeared that if you have biofilm, because again, it provides a protective layer to the amoeba and to the Legionella, it seems that it's where, there's more prevalent of the presence of Legionella. But other than that, the jury is still out there, So we don't know if lack of biofilm means that there is not a problem with Legionella. We have to do testing in the tower in order to be able to do and to be able to tell, and we're not doing enough of that to be able to tell.
I've got one last question before we ask you to see if there was anything we missed, and that is, in your new role, I'm wondering if it's, you've been there a couple of years now. I'm wondering if it's helped, if you've rethought a little bit about environmental consulting and the direction that environmental consultants take and the recommendations they make to facilities managers, and maybe if you would have changed any of the recommendations you had made, or and maybe changed the way you even presented those recommendations now that you've been in their shoes for the last 2 years?
Well, it's hard to say, Joe, because I understand what they're saying, right? The recommendations are. But to be honest, I think that all facility managers are stuck with budget constraint. So we try to do the best we can, and really we are behind the scenes. So what we do doesn't matter to people, right? I mean, if everything's go well, nobody noticed that we're here. But if it doesn't, then, people are up in arms. I would say that keep track of things. There's so many things right now. Who knew that Legionella was going to be a really big deal? It is a really big deal. I'm seeing it, almost every day, a report from somewhere. There's a Legionella outbreak. And now that I know it's only the tip of the iceberg, I'm thinking, well, our profession has so much work in front of us to help clients mitigate these issues.
You mentioned keep track of things. I think we should maybe print posters that say keep track of things.
Yes.
Because I've done work with colleges, and you go there and they don't even know where they have filters. I mean, it's like, keep track of your filters and how often they've been changed. And I just think that's some really solid, sound advice. So I'm glad I asked the question. Before we go, is there anything you'd like to add? Anything we missed, or final thoughts?
No, I mean, thank you so much for having me, and it's always my pleasure. I've been volunteering a little bit too much, so I probably back a little bit, but I always seems to get involved with fun things. So
Well, we really appreciate your volunteer work, but also you joining us here today. And it's just always a pleasure to talk to you. You're always upbeat and pleasant. And on a day when I was dealing with my taxes, I couldn't think of a better guest to talk to.
Thank you, Joe. Take care.
Lan Chi Nguyen Weekes, thanks for joining us this week on IAQ Radio. Next week, we've got Dave Kaiser coming in. We're going to talk a little, we're going to get down to the basics. How do you clean a building, He's a guy that's been in the cleaning world for many, many years. He's developed an association, actually, that did cleaning. That's now, I think, been bought by ISSA. But very interesting show next week. We're going to get back to the basics of cleaning buildings, and I think that's a really good topic for us. So before we go, I want to thank my guest today, Lan Chi Nguyen Weekes, of course, our engineer at the controls, John. You got to have faith. Cliff, the Z-Man Zlotnick, our growing group of loyal listeners. Please come back next Friday at noon for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.